Cleveland Abbe, the contested legacy of America's first weather forecaster. Esteemed colleagues and aficionados of meteorological science, welcome to an in-depth exploration of a pivotal figure whose legacy continues to provoke thoughtful discourse within our field. Today, we examine Cleveland Abbe, often heralded as America's first weather forecaster. His contributions to meteorology during the late 19th and early 20th centuries are substantial, yet they reside within a complex narrative of collaboration and contestation. Abbe's work fundamentally shaped meteorological practices in the United States, particularly through the establishment of systematic observation techniques and early foundations of weather forecasting. However, the attribution of the title Father of Modern Meteorology to Abbe is increasingly scrutinized. Critics argue that this designation overlooks the significant contributions of other contemporaneous scientists, thereby simplifying the intricate tapestry of collaborative advancements that define our discipline. In this presentation, we will delve into Abbe's formative years in education, critically analyze his scientific contributions, assess his role in establishing the Weather Bureau, explore the innovations he introduced to weather forecasting, examine the controversies surrounding his legacy, and compare his impact with that of other eminent pioneers in meteorology. Join us as we embark on this scholarly journey to discern whether Cleveland Abbe's legacy warrants singular recognition or symbolizes a more intricate narrative of collective endeavor. Early life and education of Cleveland Abbe. Cleveland Abbe was born on December 3, 1838, in New York City, a burgeoning metropolis that was rapidly becoming a nexus of commerce and intellectual activity. From his early years, Abbe displayed a profound aptitude for mathematics and the natural sciences, subjects that would underpin his future scholarly pursuits. In 1857, at the age of 19, Abbe graduated from the University of the City of New York, now New York University, with a Bachelor of Arts degree. His academic performance was distinguished by exceptional proficiency in mathematics and physics. Eager to immerse himself in the forefront of scientific inquiry, Abbe traveled to Europe to attend the University of Göttingen in Germany, one of the era's preeminent institutions for scientific research. At Göttingen, he studied under the tutelage of illustrious scholars such as Wilhelm Eduard Weber and Carl Friedrich Gauss. Under Weber, Abbe delved into experimental physics, while Gauss's influence ignited his interest in theoretical frameworks and mathematical applications. This period was instrumental in honing Abbe's analytical skills and exposing him to advanced methodologies in observational science. Returning to the United States in 1860, Abbe accepted a position as an assistant astronomer at the United States Naval Observatory in Washington, D.C. Shortly thereafter, he became director of the Cincinnati Observatory in 1868. At Cincinnati, Abbe undertook extensive observational studies, focusing on celestial mechanics and timekeeping, endeavors that required meticulous data collection and precise calculations. His experiences at these institutions crystallized his belief in the necessity of systematic observation and data integrity. Abbe recognized that the methodologies employed in astronomy could be effectively applied to the study of atmospheric phenomena. Contributions to meteorological science. Cleveland Abbe's impact on meteorological science is marked by his unwavering commitment to instituting systematic observation and rigorous analytical techniques. In the post-Civil War era, the United States was experiencing rapid expansion, and the need for reliable weather information was increasingly critical for agriculture, commerce, and transportation. Recognizing this imperative, Abbe began issuing daily weather bulletins from the Cincinnati Observatory in September 1869. Leveraging telegraphic reports from a network of voluntary observers, he crafted weather summaries and predictions that were disseminated to the public and regional newspapers. This initiative represented one of the earliest attempts at organized weather forecasting in the nation. Central to Abbe's approach was the application of statistical analysis to meteorological data. He emphasized the importance of large datasets to identify patterns and establish empirical relationships between atmospheric variables. By quantifying uncertainties and employing probabilistic methods, Abbe sought to improve the reliability of forecasts, a significant advancement over the subjective interpretations prevalent at the time. Abbe advocated for the integration of physical laws into meteorological science. He posited that atmospheric processes could be described using the principles of thermodynamics and fluid dynamics. In his 1871 paper, The Physical Basis of Long-Range Weather Forecasts, Abbe explored the potential of applying mathematical physics to understand and predict weather phenomena. Although computational limitations of the era precluded the practical implementation of numerical models, his theoretical contributions laid essential groundwork for future developments in dynamic meteorology. Abbe also emphasized the necessity of international collaboration. He was instrumental in promoting the exchange of meteorological data across national boundaries, recognizing that atmospheric systems are inherently global. His efforts contributed to the establishment of standardized observational practices and the synchronization of data collection methods, a precursor to the coordinated international meteorological efforts we observe today. While Abbe's contributions were pioneering, it is essential to situate them within the broader context of contemporaneous scientific advancements. His work was part of a collective movement toward modernizing meteorology, reflecting the interplay of ideas and discoveries among a network of dedicated researchers. Establishment of the Weather Bureau. The formation of a centralized meteorological service in the United States was a transformative development, and Cleveland Abbe played a significant role in this process. In 1870, Congress authorized the Secretary of War to establish a national weather service within the U.S. Army Signal Corps, primarily for the purpose of providing storm warnings. Abbe joined the Signal Service in 1871 as a civilian assistant, serving as the chief meteorologist. Within this role, Abbe was instrumental in structuring the operational framework of the newly formed Weather Service. He implemented standardized procedures for data collection, insisting on the use of calibrated instruments and uniform observation times. Abbe recognized that the value of meteorological data hinged upon its consistency and accuracy across diverse geographical locations. He was also a proponent of utilizing telegraphic communications to transmit observational data rapidly. This innovation allowed for the timely creation of synoptic weather maps, which were essential for identifying and tracking weather systems, a critical function for issuing forecasts and storm warnings. In 1891, the Weather Service was transferred from the military to the Department of Agriculture, becoming the Weather Bureau. Abbe continued his service, contributing to its evolution into a more scientific and public-oriented institution. He oversaw the expansion of observation stations, the development of educational programs for meteorologists, and the dissemination of weather information to the public. However, attributing the establishment of the Weather Bureau solely to Abbe would be an oversimplification. The groundwork for a national weather service was laid by individuals such as Increase Lapham and Admiral Robert Fitzroy of the British Meteorological Office, whose earlier initiatives demonstrated the feasibility and necessity of organized meteorological services. Additionally, legislative support and public demand were critical factors in the Bureau's creation. Innovations in weather forecasting techniques. Abbe's innovations in weather forecasting were grounded in his application of scientific principles to the atmospheric sciences. He was a strong advocate for the synoptic method, which involves the simultaneous observation of meteorological variables over a wide area to construct a comprehensive picture of weather systems. He introduced the practice of plotting isobars and isotherms on weather maps, enabling the visualization of pressure systems and temperature gradients. This allowed for the identification of cyclones, anticyclones, and frontal boundaries, concepts fundamental to modern weather analysis. In his theoretical work, Abbe emphasized the significance of thermodynamics in understanding atmospheric processes. He explored the concepts of adiabatic heating and cooling, the role of latent heat in phase changes of water, and the behavior of air masses. His insights into the energetics of the atmosphere contributed to the development of theories on cyclogenesis and storm development. Abbe also recognized the limitations of existing forecasting techniques and the potential for improvement through mathematical modeling. He laid the conceptual foundation by advocating for the use of differential equations to model atmospheric dynamics. Moreover, Abbe was keenly aware of the importance of error analysis and uncertainty quantification. He introduced the use of confidence intervals and probabilistic forecasts, acknowledging the inherent uncertainties in predicting complex, nonlinear systems like the atmosphere. This probabilistic approach is a cornerstone of contemporary ensemble forecasting techniques. Abbe's contributions were a vital link in the chain of scientific progress that has led to the sophisticated forecasting models we utilize today. Controversies surrounding his legacy. The legacy of Cleveland Abbe is not without its controversies, stemming primarily from the attribution of the title Father of Modern Meteorology. Scholars argue that this epithet oversimplifies the collaborative nature of scientific advancement and marginalizes the contributions of other key figures. Historian Gregory F. Romano posits that the narrative elevating Abbe to singular prominence was influenced by Abbe's own self-promotion and the historiographical tendencies of the period. Romano highlights the essential contributions of Increase Lapham, who, prior to Abbe, had systematically collected weather data and successfully advocated for a federal weather service. Furthermore, critics contend that while Abbe advocated for the application of physical laws to meteorology, he did not directly develop the numerical models that underpin modern forecasting. Pioneers such as Wilhelm Bjerknes and later Louis Fry Richardson were instrumental in formulating the equations and computational methods that would eventually be realized with the advent of electronic computers. Additionally, there is an argument to be made regarding the collaborative ethos of the scientific community. By focusing on a singular father figure, there is a risk of perpetuating a great man narrative that overlooks the interconnected contributions of numerous scientists. Abbe himself acknowledged the importance of his contemporaries and the international community. He understood the value of collective endeavor in advancing the science. Re-evaluating Abbe's legacy involves recognizing both his significant contributions and the contributions of others. This perspective fosters a more accurate and equitable historical understanding, highlighting the rich tapestry of collaborative progress that defines meteorology. Comparisons with other meteorological pioneers. To contextualize Cleveland Abbe's role within meteorology, it is instructive to compare his contributions to those of other key pioneers. Increase Lapham was instrumental in initiating federal meteorological services in the United States. His efforts led to the formation of the Weather Service under the U.S. Army Signal Corps in 1870, predating Abbe's involvement. William Ferrel made groundbreaking theoretical contributions to understanding atmospheric motions. His formulation of the deflection of winds due to the Earth's rotation provided critical insights into the behavior of large-scale atmospheric circulation. James Pollard Espy was one of the first American meteorologists to develop theories on storm formation and convection. His publication presented ideas on the thermodynamics of the atmosphere and the role of latent heat in weather systems. These individuals, among others, collectively advanced meteorology through their respective areas of expertise. While Abbe's strengths lay in organizational leadership and the promotion of systematic scientific methodologies, the theoretical foundations and practical applications were often the result of collaborative efforts. Conclusion. In summation, Cleveland Abbe's role in the development of meteorological science is both significant and emblematic of the collaborative nature inherent in scientific progress. His dedication to implementing systematic observation, advocating for a national weather service, and introducing rigorous scientific methodologies substantially influenced the trajectory of meteorology in the United States. However, the designation of Abbe as the singular father of modern meteorology overlooks the indispensable contributions of his contemporaries, individuals whose work was equally transformative. The advancements in our field are the culmination of collective efforts, interdisciplinary collaboration, and the relentless pursuit of knowledge by many dedicated scientists. As experts and scholars, it is incumbent upon us to critically evaluate historical narratives and to acknowledge the multifaceted contributions that have shaped meteorology. By embracing a comprehensive perspective, we honor the legacy of all who have propelled the science forward. Closing. Thank you for joining this exploration into the contested legacy of Cleveland Abbe. Your engagement in such discussions enriches our collective understanding of meteorological science. We invite you to share your perspectives and insights in the comments below. If you found this presentation informative, please like the video and consider subscribing to our channel for more in-depth analyses of pivotal topics in meteorology. Together, let us continue to advance knowledge within our field. Until our next discourse, stay inquisitive and keep your eyes on the skies.